everyone, and this presentation is all about basic image processing and computer vision, focusing on two important pre processing techniques, resizing an image and thresholding. These are among the first operations performed before applying machine learning or deep learning models. So, let's understand why they are more important. Before jumping into resizing and thresholding, let's first understand the basic stages of image processing in computer vision. The first stage is nothing about it, is simply means capturing an image using a camera, mobile phone, CCTV, drone, satellites, or any image sensor. Without an image, computer vision cannot be behind. Next comes image enhancement. Here, we improve the quality of the image by resizing it, removing the noise, adjusting the brightness, contrast, or sharpening details. This helps the computer understand the image much better. After, segmentation comes to divide an image into meaningful parts. One common technique is thresholding, where objects are separated from background. This makes detection much easier. Finally comes feature extraction. In this step, the computer identifies the important features like edges, corners, textures, shapes, and patterns. These features are then used for tasks like object detection, face recognition, medical image analysis, and self driving cars. Now, let's see about resizing an image. Image resizing means changing the width and height of an image without changing what is actually inside it. We can either make the image larger or smaller depending on our application. How resizing works? When we resize an image, the computer changes the dimensions by adding or removing pixels. Since new pixels may need to create a OpenCV uses interpolation technique to estimate the pixel values while maintaining the image quality. Resizing can be done either by giving a fixed size like 300 by 300 pixels or by giving a scale percentage such as 50% of the original size. Let's see the actual step. First, we load the image using OpenCV. Next, we resize it using cv2.resize function. We can either provide a fixed dimension or a scaling factor. Then we choose an interpolation method. Interlinear is mainly used when enlarging image because it gives smooth results. Interarea is mainly used when reducing image size because it preserves image quality better. Finally, we display or save the resized image. Now, we have learned how image size can be adjusted. Let's move on to another powerful pre-processing technique called thresholding. Thresholding is an image processing technique that converts a grayscale image into a binary value, meaning the image contains only black and white pixels. It compares every pixels with a threshold value. If the pixel value is greater than the threshold, it becomes white. If it is smaller, it becomes black. This makes it much easier for computer to identify objects from the background. The steps are very simple. First, load the image, convert the image into grayscale because thresholding works on intensity values. Then apply one of the thresholding technique. Simple thresholding uses one fixed threshold value for an entire image. Adaptive thresholding calculates different threshold values for different regions of the image. This works well when lighting conditions are uneven. Otis thresholding automatically finds the best threshold values without specifying it manually. Finally, the processed image is displayed or saved. To conclude, image resizing changes the dimension of the image while preserving its content. Thresholding converts grayscale images into binary images, making objects much easier to detect. OpenCV provides efficient functions like resize threshold to perform these operations quickly. These pre-processing techniques improves the accuracy of computer vision. Applications such as face recognition, OCR, medical imaging, autonomous vehicles, and object detection Alright, we have understood the concepts behind resizing and thresholding, but computer vision isn't about just theory. It comes alive when we actually see it working. So now let's jump into an hands-on demonstration and understand the code step by step. First is image resizing. First, we import the OpenCV library because it provides all image processing functions required for this program. Next, we load the input tree image for the specified location into the program. After loading the image, we create a fixed size resized image of 300 by 300 pixels using linear interpolation to maintain smooth image quality. Then we define a scaling factor of 50%. Based on this value, the program calculates the new width and height of the image. Using these calculated dimensions, another resized image is created. This time, inter-area interpolation is used because it gives better quality when reducing the image size. After resizing, the program displays all the images in separate windows for comparison. The program waits until the user presses a key, then close all the display windows. Finally, both resized images are saved into the computer for future use. Now let's see how the output looks like. The original image is the input image before any processing. Then fixed size resize image is the resized to an 300 by 300 pixels. Scaled resize is the image that is reduced to 50% of its original size while maintaining good image quality. From these outputs, we can clearly observe that resizing changes only the dimension of the image while preserving its visual contents. Let's move to the next pre-processing technique, that is thresholding. Just like previous program, we first import the OpenCV libraries and then load the input images. Since thresholding works only on a grayscale image, the first processing step is converting the image into grayscale. Next, the program applies simple thresholding, where one fixed threshold value is used for the entire image. After that, adaptive thresholding is applied. Instead of using one threshold value, it calculates different threshold values for different region of the image, making it suitable for image with the uneven lightnings. Finally, auto thresholding is performed in this method. OpenCV automatically finds the most suitable threshold value without any manual input. After applying all three thresholding techniques, the program displays every output for comparison. The program then waits for the key press and closes all the display windows. Then the output looks like first is grayscale image shows the original image converted into the grayscale image. Then simple thresholding uses one fixed threshold value to create a binary image. Then adaptive thresholding uses different threshold values for different region, producing a better result under varying light condition. Then auto thresholding automatically calculates the best threshold value and generates the binary image. By comparing these outputs, we can clearly understand how different thresholding techniques perform and which one is more suitable for different image conditions. So, that's the complete workflow from capturing an image, resizing it for consistency, and applying thresholding to clearly separate objects from the background. These may look like simple pre-processing steps, but they are foundation of almost every computer vision system. In the world of computer vision, every intelligent decisions begin with a well-processed image. Great AI doesn't just learn from data, it first learns to see the world clearly. Thank you.